A new info stealer called LumaC2 is being distributed disguised as illegal programs such as cracks and keygens. Other malware such as CryptBot, Redline, VDAR, and Record Breaker, Raccoon V2, are distributed in a similar manner. It appears that the LumaC2 stealer has been available for purchase on the dark web since the beginning of 2023, and since March, it has been distributed by a threat group disguised as a crack. Although this method of malware distribution is mostly used by Record Breaker, Raccoon V2, LumaC2 stealer is also being discovered from time to time. The LumaC2 stealer was first discovered on March 3rd, and additional distributions were confirmed on the 12th and 20th of the same month, indicating an approximate activity rate of once a week. Users searching for a crack or serial key for a particular popular software are led to a malicious website. After clicking the download button on this website, users will be redirected several times before arriving at the page where the malware is distributed. When users access the URL displayed on the web page or click the download button, they will download the malware in a compressed format. This process can occur through the threat actor's own established server or services, such as MediaFire or Mega. The first sample distributed through this method downloads a compressed file called new setup v4 pass 55551.rar, which contains another compressed file named setup.rar. Upon decompression, setup.rar creates LumaC2 disguised as setup file exe. Let's perform a deeper analysis of this malware. To date, LumaC2 has had 3 different forms when distributed as a crack. Below are details on the primary samples of each type. The first type that has the same appearance as CryptBot and also installs ClipBanker. Type 2, that downloads a malicious DLL from a C2, and third type where the distribution field itself is LumaC2. The malware performed string obfuscating by incorporating multiple EDSEUS65 strings between the strings used for malicious behavior. By modifying the values of specific variables and using numerous conditional statements and jump statements for most of the code, the malware is able to control the execution flow. It is suspected that this was done to hinder analysis efforts. When APIs related to malicious behaviors are used, functions such as import table or get proc address are not used, but instead the loaded target DLL is directly accessed to obtain the API address. The malware only has the calculated value of the function name and finds the function with the same value out of the function names defined in the export table of the target DLL. This is a method often used by malware to hide the API used in their activities. In the early stage of execution, there are 3 functions that appear to be for the purpose of anti-sandbox. When certain conditions are met in each function, a perpetual looping function is executed to crash and terminate the process. A crash occurs when a DLL named TERS-ALREC-STD v19.dll is successfully loaded. This DLL does not exist in ordinary systems and is assumed to be for the purpose of evading certain analysis environments, such as sandboxes, or to be used as a kill switch. The sleep and getSystemTime as fileTime functions are used to check the elapsed time value between sleep functions. A crash occurs if the sleep function is ignored. A crash occurs if the value from calculating the account and computer names matches a certain value. The values compared to are 056CF7626 and 0B09406C7, which have been confirmed to be John Doe and Hal 9th, respectively. These account and computer names are known as Windows Defender Emulator Environment values. This feature is also included in the VDAR malware, which is being distributed in the same attack. However, this function does not run correctly. While the feature of checking the username is actualized correctly, the computer name string length is compared against the value 7 instead of 6. Unlike getUsernameW, the getComputernameW function does not include a null character when returning the string length. This is believed to be an error on the malware creator's side. The reception of commands or configuration values from a C2 has not been confirmed. The InfoStealer target is designated by the malware itself, and differs slightly with each distribution sample. After the information is collected, it is compressed into a zip and transferred using the following method. The HTTP post method is used when transferring to the C2, where the path is C2 sock and the user agent is Tesla Browser 5.5. The following information is included among the data that is sent to the C2. This string is assumed to be the name and build version of the malware. The recently, March 20th distributed sample also has the same build version. LumaC2, build 2023-3101. The analysis of the information targeted for theft based on the execution flow and strings is as follows. The theft target list can differ per sample. Browser data, Chrome, Chromium, Edge, Cometa, Opera Stable, Opera GX, Stable, Opera Neon, Brave Browser, Komodo Dragon, Cock, Firefox. Cryptocurrency wallet. Programs, Binance, Electrum, Ethereum, Exodus, Ledger Live, Atomic, Coinomi. Screenshots. All TXT files up to 2 folders deep in the %user profile sent directory. System information. Installed program information. Email clients. Windows Mail, the Bat, Thunderbird, Pegasus, Mailbird, EM client. Other applications. AnyDesk, FileZilla, KeePass, Steam, Telegram.